Hi friends. Hi friends. Thanks for tuning in. My name is Dr. Mary Sunderland and I am the Director of Research and Education here at the Foundation Fighting Blindness in Canada. If this is your first time joining us, welcome to our April e-news follow-up Facebook Live session. This session is going to be focused on the latest developments in drug therapies and stem cell therapies for blinding eye diseases. And welcome back to our monthly participants. It's great to see you online. I really do look forward to these live sessions every month. It's such a great way for me to learn more about the research that matters to you. So thank you for sending in your questions. And it's really fun interacting with you online. I get to know you a bit better, but I do hope that many of you will consider attending one of our in-person events that happen across Canada. So check out our website at ffb.ca to learn how you can meet some of us here in the office in person this year. So today I'm going to be talking about the 3 stories that were featured in our April e-news that went out just this past Tuesday. I'm going to start by talking about, really a monumental stem cell discovery that was making headlines last week. After that, I'm going to be talking about the stem cell research that's happening in the lab of Dr. Gilbert Bernier in Montreal. And finally, I'm going to finish off talking about the research that's being led by Dr. Philippe Monnier here in Toronto and his work to develop a new sight-saving drug. So I'm going to answer questions kind of along the way, but for new questions that come in during the session, I'm going to protect time at the end to answer questions then. So let's get started. This first story that I'm going to talk about has a long title. And I'm going to read out the whole title because we really did select every word carefully because each word really conveys why this particular discovery is quite meaningful. So on our website, the story is called World's First Experimental Therapy Involving Reprogrammed Stem Cells from Another Donor Aims to Treat Macular Degeneration. So that's a mouthful, I know. So why is this such a game-changing study? Well, first, it's not just your ordinary clinical trial. This trial made headlines, newspaper headlines around the world, and was also published in one of the top science journals called Nature. And the reason for that is it was the very first time that a special kind of cell that's called induced pluripotent stem cells, or iPSCs for short. It was the first time that this kind of specialized iPSC cell was reprogrammed and taken from a particular donor, reprogrammed, and then put into a person living with a blinding eye disease. So why does that matter? Well, it matters for a few reasons. But before I go on, I just saw some great news that Jason Cherish, who works in the lab of Philippe Monnier, is tuning in online. So we're going to get some real insider scoop a little bit later on when we're talking about Dr. Monnier's work. So back to this session about, back to the first story about this new iPSC or reprogrammed stem cell trial. So we've been talking about stem cells as a potential treatment for retinal degenerative diseases for a long time. And there's a lot of different things in the works. And age-related macular degeneration is the most common form of blindness that affects people over the age of 55 around the world. And in this form of vision loss, there is a type of cell in the eye that is really affected. It's called the retinal pigmented epithelial cell. It's called RPE cell for short. Now these cells are really important. They form a thin single cell layer that is between the photoreceptor cells. They provide support to the photoreceptor cells, and they're also connected to the vasculature below. So what happens in age-related macular degeneration and other forms of macular degeneration is this RPE cell is damaged, and as a result, the photoreceptor cells start to die. And those photoreceptors are the cells that are really essential for vision because they detect the light. So we're always talking about photoreceptors here at the Foundation Fighting Blindness. So this particular trial that happened in Japan, people have been trying to fix this RPE cell layer. Actually, they've been trying to fix it since about the 1990s with various efforts. And what's happened is that immune rejection has been a big, big problem. So you transplant these RPE cells in, and then the immune response kicks in, and the graft gets rejected. And so there was a big leap forward in 2014 when this group in Japan at the Riken Institute learned how that they could take skin cells from an individual, and then you take the skin cells, sort of expose them to a chemical cocktail that will coax them into becoming a stem cell. Stem cells are really exciting because stem cells can make any type of cell needed to build a human body. And this iPSC cell, this induced pluripotent stem cell, what's really cool about it is that you can make these stem cells from skin cells. Now, the person who discovered this, based in Japan, Dr. Yamanaka, he actually received a Nobel Prize for learning this discovery. So the thought is that, wow, you could make personalized treatments for everybody. You could just take their skin cells, turn them into stem cells, then make them into retinal or eye cells, implant them into the individual. But the problem with that is it's really hard to imagine doing that for every single person who needs it. That would be very expensive and require a lot of resources. But in addition to that, if you're trying to cure someone or treat someone that has a disease, perhaps that disease is also affected in other cells of their body. So you really want to replace the damaged cells with healthy cells. And so that's what this group, that's what many different groups around the world are trying to do. And this big breakthrough in Japan was that they figured out how they can get kind of the skin cells, turn them into stem cells, turn them into vision cells, eye cells, specifically retinal pigmented epithelial cells, and then sort of treat them in such a way that the host, the person that they're going to transplant them to, won't reject them. We don't want to have that immune response where they get rejected, because in all of these ongoing stem cell clinical trials, the immune response is something that has been a real challenge. And actually, when some of these trials have involved immunosuppressant drugs or drugs to help with it, that's kind of the biggest factor that causes negative side effects. So we're really hopeful that this kind of opens the door to the fact that these iPSC cells could really treat a whole variety of blinding eye diseases. So think about how we have blood banks around, based on what your blood type is, you can get a specific kind of blood. If you are in an accident, you need a blood transfusion. We've set up a whole system to deal with this with respect to blood. So this idea of tissue banking, stem cell banking, banking induced pluripotent stem cells for the treatment of a variety of diseases, this paper really shows this is possible. It's kind of what you call a proof of concept. Hey, this thing looks like it might just work. So that was a really exciting day for us. And we've been following this group since 2014 when they first started their initial trial, and we're going to keep following them because there's really exciting stuff happening. And now I'm going to shift to some of the specific questions related to that story. So, of course, one of the most popular questions asked by many of you is whether this specific trial was going to be able to restore vision or simply stop vision loss. That's a great question. And I'm really glad that that question is being asked because those details matter a lot. And with this particular trial, remember earlier I was talking about those specialized RPE cells, the cells that are sort of acting as a support layer for the photoreceptor cells. Those cells, those RPE cells, by replacing the RPE cells, you're not going to restore vision. You're not going to give people back the vision that they've lost because those RPE cells do not detect the light. They are simply kind of acting as that support structure to the photoreceptor cells. And so the thought is that by replacing that layer with healthy RPE cells, you could prevent further vision loss. That's the hope with this particular trial. And we have seen some very promising evidence that this approach could actually stop vision loss in the disease that they're looking at in Japan is wet age-related macular degeneration. So currently that disease is treated with regular injections of anti-VEGF drugs to the eye. And in the Japan trial, they stopped doing the injections, transplanted this RPE cell layer, and saw that they were able to stop the further progression of vision loss. So with this specific trial, that is the goal. It's for macular degeneration. So it could work for perhaps for the dry form of age-related macular degeneration, and another kind of related disease where those cells, those RPE cells, are involved is Stargardt disease, which is a form of kind of juvenile macular degeneration. So another follow-up question is, Josette actually asked a really important question. She says that her family's affected by RP, and they had heard that you could already cure RP with stem cells. So Josette, I'm sorry to say, but we cannot cure RP with stem cells right now. And I would actually, I encourage you to reach out to us. Send us a private message if you want to share the story, because I'm really curious to learn more about where you learned about this potential cure, and maybe what sources, maybe you read about it on the internet, or just through word of mouth, because we're really trying to take note and keep track of all of the different places that are saying that they have cures for retinitis pigmentosa, because those claims make us feel really, really worried, because there is not a cure right now. And if you go and you let people who don't really have cures try them on you, it's not going to work out well. So we really discourage people from doing this. Please let us know where you're hearing this information, because we want to learn more about it for you. And there are actually a number of trials that are testing if stem cell-like cells might work to treat a form of later stage retinitis pigmentosa. But again, this is not a trial that aims to restore vision, because it's not actually putting in photoreceptor cells. Photoreceptor cells are the cells that detect light. Those are the cells that you would need to replace in order to restore vision. And the trial that's happening involving stem cell-like cells, they're kind of retinal progenitor cells. This trial is happening in California, funded by the California Institute of Regenerative Medicine, and it's led by Dr. Henry Klassen. It's a trial that is injecting cells into the vitreous of the eye, into the middle of the eye, and hoping that these cells, the cells give off some kind of growth factors, some kind of chemicals, I guess is one way you could refer to it. And the hope is that those factors will prevent further cell death. So that's the only sort of legitimate trial I know of right now, but again, it's not a restorative and certainly not a curative trial. The next question that I had is, I guess I already addressed it a little bit, but a lot of people asking about what are the implications of this study for other eye diseases besides macular degeneration. So I've sort of already addressed that, and I pointed out that because this specific trial is looking at replacing those RPE cells, it's especially relevant to any disease, any vision disease, where the RPE cells are damaged and where that damage is involved in vision loss. So that's a pretty sort of top-level answer, but I give that answer in that way because it's really important for you to understand as much as you can about your own eye disease. Maybe you know what it's called, and you can look up, you can visit the ffb.ca website to learn more about the specifics of what is happening to cause that vision loss. because it's that knowledge of that kind of disease biology that is going to help you to answer those questions of, will it work for my disease? And I've sort of been looking at what else the Riken group, this is the group in Japan, what else they're working on, and that's really a take-home message from their group. So they warn, they say they're working on some stuff related to retinitis pigmentosa. We can actually provide a link in the comments section. We wrote about it earlier in January. They had an animal study related to the work they're doing for retinitis pigmentosa. And they had some really nice preliminary results of restoring vision in mice. And really reiterating that in order to know if this is going to work for your specific kind of retinitis pigmentosa, you need to know more about, is it the photoreceptors that are dying, and how are they dying, and what can we do to save them? So really understanding that disease biology is important to be able to answer the question. And that leads right into the question asked by Sandy, Wilco, Maria, Sofo, who are all asking, what are the implications for people who are living with RP? The implications, there are important implications. One of them that really can't be overlooked is this entire regulatory story that is going to be pioneered and is actively being pioneered by the group in Japan and by others around the world who are doing sort of first in human studies with stem cells. And so a lot of, people are often asked about the question, a really popular question is, how long before there's a trial that I can sign up for? Like, how long before it's going to work for me? And so there's the science piece, and we can sort of make predictions about what else needs to be figured out in the science space. And then before you can move it out of that laboratory space where you're working in laboratory models, animal models, before you can test something in a human, a first in human trial, we want to make sure that it's as safe as possible. And there are a lot of hesitations around those first in human stem cell trials simply because it's unknown. This is pioneering a new path forward, and we really want to make sure that we're trying to cure your eye disease. We don't want to end up giving you another disease by injecting, cells where perhaps we shouldn't. And so there's a whole regulatory space, tons of figuring out exactly how can we do this in the best possible way. And those details are being figured out right now. And so that is going to really accelerate the next wave of trials. And we're certainly hopeful that RP will be and continue to be in that next wave of trials. So it's the Takahashi group. This is the group in Japan at the Riken Institute. They're working on RP. There are a number of groups who receive funding from the Foundation Fighting Blindness, who are also working on how stem cells could be a potential treatment for RP. So we'll certainly continue to talk more about this here. So moving on to the next question. Actually, I think I addressed most of the questions. If you have more questions about that story, keep them coming, and I'll go back on afterwards and look at those comments that are coming in. But now I'm going to shift gears and go into the next story, which really flows nicely from this first one. And the next story is called, on our website, if you want to go check out and read the full story, it's called The Biology of Treating Blindness with Stem Cells. So this is a focus story that we did on a stem cell researcher based in Montreal, Dr. Bernier. And Dr. Bernier has been working on trying to understand the biology of the stem cells and how he could possibly take stem cells and coax them, encourage them to become very precious cone photoreceptors. So you need to know that in your eye there are two different kinds of photoreceptors. There are the rod photoreceptors. Those are the cells that are really important for vision in low light environments and for peripheral vision. And then there are cone photoreceptors. Those are the cells that are very important for high acuity, color vision, central vision. And so Dr. Bernier has really focused for the past almost 20 years trying to understand that biology of cone photoreceptors. And about 2 years ago, he published a truly game-changing study where he could show that he could take stem cells and in a very quick time span, like people are amazed at how fast he can do this. He can get relatively pure populations. When I say pure, it's like, most of the cells end up being cone photoreceptors. And the really cool thing is that the way they become those cone photoreceptors, it seems to be kind of, like it looks a lot like what happens during the regular course of development. So when he, subjects the cells to his chemical cocktails, and the chemical that he's really interested in is called cocoa. And when he, adds cocoa to his cells, they become cone photoreceptors and they self-organize, and he can make these beautiful sheets of cone photoreceptors. And so since making that discovery, he's been really trying to line up, trying to get everything organized so that he can test these sheets of cone photoreceptors as a potential treatment for diseases where those cone photoreceptors are lost. And so the disease that he sees as kind of the most obvious disease, the first disease that he thinks he'd like to treat with this is Stargardt disease. So again, I was speaking about it earlier. Stargardt disease is kind of a form of juvenile macular degeneration where there is that central loss of vision involving cone photoreceptor cells. But recall, the RPE cells are also involved in this disease. So whether Dr. Bernier will end up, working with transplants that involve both cones and RPE cells or just cones, like these are some of the things that he's thinking about right now. So we are really encouraged by all of the forward momentum that's happening with him and his team. He started a company to try and get the whole commercialization piece worked out. He sorted out exactly the work that he needs to do before going into the clinic. So he's built a really clear plan of what he needs to do to get that first in human clinical trial ready to go. And so we're really encouraged by this work. And again, in talking to Dr. Bernier and people really wanting to know, this is exciting, like, will it work for me? He is very hesitant. Scientists are trained to be skeptics and to be very careful, and I think he's hesitant to overpromise, and we're hesitant to overpromise too, but we like to think big and be very hopeful here at the Foundation Fighting Blindness. So because his work involves replacing cone photoreceptors, we're very hopeful that it could potentially work as a restorative, regenerative approach for any kind of eye disease where that central high acuity vision is lost with the degeneration, with the death of those cone photoreceptors, because his plan is to replace them. And so I'm going to go a little bit more and address some of the questions that people are asking. So Joy Lynn chimed in with a comment that, this is really exciting. I agree, Joy Lynn, very exciting. How far away from clinical trials? So this is a question that many scientists hate answering. They don't like answering this question because nobody wants to overpromise and then fail to deliver. And the trouble with science is that you can make very careful, well laid out plans. And scientists do. I mean, you should see the grant proposals that come into this office. When we're trying to decide who is the best team to receive funding from the Foundation Fighting Blindness, these scientists come in with detailed plans that are more than 100 pages long to really, really describe their plans of what they're going to do, when they're going to do it, how long it's going to take. But the trouble with science is that there are always unknowns. So you can never be like entirely sure. And so I always remind scientists that they're amazing planners, that they're great at predicting what's going to happen. And so I like to push them, be like, come on, tell me, how long do you think it's going to take? But they always have to say, you know what? There are a lot of unknown factors, so you can never be 100% sure. But you know what? You can rarely be 100% sure about anything. So with Dr. Bernier, I know if everything goes, in a perfect world, everything goes as planned, he's really hopeful that he could be in that first in human clinical trials in less than 5 years. And we'll just have to wait and see. And one of the biggest limiting factors, the thing that can really accelerate how fast we get there, is how much money we have. Because this kind of work, it costs a lot of money. And as you get closer to being in that first in human trial and you're working on getting cells to be safe enough to put into humans, you're working on testing models that would be, give you a pretty good prediction about whether it would work or not, that work's really expensive work. So that's why we do tons of fundraising here at the Foundation Fighting Blindness. And that's why our new grant competition this year, the Restore Vision 2020 competition, which I talked about during the March Facebook Live session, we're trying to give out larger grants to scientists because we know that as they get farther along, they need more money to do their work. So going on to the next question, both Dave and Linda are really curious to know if they could just visit Dr. Bernier and get some of those cells injected, or get in line to make sure that they're front of the line when and if this clinical trial is ready to start. And so my answer to both Linda and David and to everybody out there, you need to get yourself signed up on the Foundation Fighting Blindness patient registry. So we'll make sure that there are instructions about how to get to that page in the comment section. This is our database. Really, in the most basic description, it's a database, and people can sign up through their doctor. It's really like a transfer of medical records. And once you're on the patient registry, you're part of this anonymized database where we know about your eye disease history. And so when a trial comes, we're going to go to that registry and we're going to figure out who are the best people who stand to benefit from participating in this trial. So Foundation Fighting Blindness patient registry, get yourself on there. I see a question is coming in from Gary, who's asking, would you ever know if someone would be too old to be part of the clinical trial? It's a good question, Gary. And usually there is not an upper age limit. I'm often looking at clinical trials. So clinical trials have things called inclusion and exclusion criteria. So when you're looking at, what do you need to have happening to you to be a part of it? And is there anything that would eliminate you from being a part of this trial? I've never seen an upper age limit as being one of the exclusion criteria. It's actually more common to see a younger age limit as being an exclusion criteria, because you have to remember that a clinical trial is an experiment. So when you enroll in a clinical trial, you don't know if this is going to work for you. That's one of the risks that you're undertaking. And when you are doing experiments with children, they're a vulnerable population, and there's a lot more that you need to consider. So it's actually much more likely to see younger ages being excluded from trials. And so it's actually noteworthy, the trial that I was talking about earlier involving age-related macular degeneration in Japan, the woman that was a part of that, there was one woman who entered the trial in 2014, and she was 78 at the time. So perhaps still a spring chicken. I've never seen a picture of her, but she's certainly past the age of retirement. So whether what you need to know is if age is going to be a limiting factor, it's going to be specific to each trial. So there's no blanket rule like once you're over 80, forget about it. I think, in fact, if you have quite low vision and you're older, for example, with the bionic eye, the Argus trial, some of those early participants in that trial were older with quite low vision, because they're willing to take that risk, because if they had a little bit of vision, they're maybe willing to lose the rest of it. So hopefully that helps you understand how we put limits on who can and can't be involved in the clinical trial. Okay, moving along now to our final story. Is Jason still with us? Hopefully he's still there. because Jason, this is your chance to correct me if I say anything wrong, because the paper I'm talking about next is the work that's being done in the lab of Dr. Philippe Monnier, and Jason is doing a lot of that work, and perhaps some of you have had a chance to meet Jason at our in-person education events. He's still there? Wonderful. So I'm going to see if I can channel the work that Jason's been doing, and I'm glad that he can chime in if there's any specific questions that he can add to. So the story title, if you want to look up and read the full title on our website, is Halting Cell Death to Save Vision. And this has been kind of in the works for a long time. So this is a great story about a beautiful basic science discovery leading to all kinds of clinical applications. So Dr. Philippe Monnier, he's certainly a scientist by training, and he made a truly groundbreaking discovery more than a decade ago. And what he discovered was that there was this protein called neogenin. And neogenin is on the receptors. It sort of covers, imagine your cells have little things on covering them. So there's little neogenins covering your cell. And he noticed that this neogenin seems to really play a role in whether those cells stay alive or die. And when there's more neogenin, the cells seem to die more. And that's true. What he's been amazed is this is true in all kinds of neural cells or brain cells, nerve cells. We can refer to them by different names. And so we were really encouraged and so happy when he decided to check out, hey, maybe neogenin could also be involved in forms of vision loss. So he took some of the work that he was doing in stroke and took a look at some different models of eye disease. So he's looked at models of retinitis pigmentosa, he's looked at models of glaucoma, he's looked at models of age-related macular degeneration, and lo and behold, neogenin seems to play a really important role in cell death. And by sort of tweaking around with what neogenin is doing, kind of stopping it from doing its thing, he can stop those cells from dying. And more than that, more than just stopping the cells from dying, in the vision models that he's looked at, he can stop the cells from dying, improve the vision that's happening, improve the functioning of the cells that remain, and also what it seems to be the visual acuity. So Jason, chime in if I've made any errors there, but we're so enthusiastic about these results because it seems to be that the drug that Dr. Monnier has developed to sort of work with neogenin seems to perhaps have the potential not just to stop further vision loss, but perhaps also to restore a bit of vision. Because the thought is that there might be some cells in there that are not quite dead. Maybe they're almost dead, so they're not working well. And if we could get in there and kind of reactivate them, get them going again, you can actually improve some of the vision that's been lost. So we're really enthusiastic about the work that he's been doing. Dr. Monnier, I often speak with him. He's so committed and so focused on getting this drug into a clinical trial where he could test it on people. And we are right there with him. I mean, we can't get this moving far along fast enough. Fast enough, far along? Both? So we're just really, whenever he has some really exciting new data, he shares it with us. And just fantastic stuff coming out of that lab. A lot of it thanks to the work that Jason has been doing. We're so glad that he's online with us here today. So some of the questions that came in about Dr. Monnie's work are really asking from Omima and Sofo, asking, when will this treatment be available? Of course, this is a question that we all care about, and I kind of got into this earlier, where it's a question that I really care about, and everybody here at the Foundation Fighting Blindness cares about too. And we are really working closely with our scientific teams, with everybody who receives funding from us, to try and understand, what is your path to get into the clinic? Like, I know that specific timelines are hard to promise that you can get there, but at least show us that you're planning to get there. Like, We really want to know, what other animal models do you need to look at? What other kinds of data do you need? What do you need to get there? And how can we help you get there? So Dr. Monnier, he's pretty confident that with the right support, he could be in the clinic in less than 5 years. So this is, again, something we're really excited about. And I have to say that it's thanks to amazing Foundation Fighting Blindness donors that we were able to get someone like Dr. Monnier looking at vision in the first place. I mean, he wasn't even looking at vision until we were able to fund him to kind of check out, hey, is this the kind of thing that could potentially save vision? So it's a beautiful story that shows the impact that FFB donors can have on driving the development of new treatments. And now we're at a place where, if we want to get there faster, certainly having more money would help. So if you want to speed up that space from here to there, please consider making a donation to the Foundation Fighting Blindness. And the other thing that I was reiterating earlier, the other thing that you can do in addition to helping us fund the research that we fund, is sign yourself up for the patient registry, because that helps raise awareness about the incredible need for these treatments. So when, part of what we're doing to try and raise awareness about the need for Dr. Monnier's work to move faster is we want to be able to go to government, go to decision makers, go to industry and say, look at all these people who are ready and waiting and need this treatment. So that's really what the patient registry can do for us. And the next question from Natalie. Natalie's wondering how the work that Dr. Monnier is doing, how would that work perhaps affect patients who are living with Stargardt's disease? So that's another good question that I can kind of build on some of my earlier comments as well. And so in order to understand if the work that Dr. Monnier is doing would work for you and your specific disease, you really need to learn more about the biology of your disease. What are the cells that are dying, and is there a way that if we could stop the death of those cells, we could stop the loss of vision? So in Stargardt's disease, I would say, there's actually a great chance that Dr. Monnier's drug could impact Stargardt's, because he has a lot of data to show that it does work in models of age-related macular degeneration. And you can remember that that disease actually shares a lot of similarities with Stargardt disease. So you have good reason to be hopeful that it could also impact Stargardt disease. And then the other thing that I wanted to add about, one of the reasons we're so excited about Dr. Monnier's work is when we think ahead and we think about all the treatments that people are working on and what's going to work and what's not going to work, we certainly think about how combinatorial treatment approaches might play a role in the future. So what do I mean by that? Well, for many different diseases, there's not a one-shot cure-all treatment. For many diseases, you require, this vitamin and this drug and this prescription and, taken in different combinations at different times of the day. And that's how we've been able to get better and better at treating a whole array of different diseases. And so we think that with vision, there's certainly going to be something similar happening. And because Dr. Monnier's drug has such a positive effect on preventing cell death, you could see that perhaps you might want to be taking Dr. Monnier's drug in addition to having a stem cell transplantation therapy, because one of the challenges with getting stem cell transplantation therapies to work is, when you're doing that transplantation, a lot of the cells die. So what if you could add Dr. Monnier's drug to a stem cell treatment and then, prevent that cell death? So great. I see a comment coming in from Jason. Oh, perfect. Jason is saying that he actually has some evidence that the mechanism, so when scientists talk a lot about mechanisms, it's like, how is that drug working? What's it doing? So Jason says they have evidence in the lab that it could work for Stargardt disease. So thank you, Jason. That's really exciting news. So get back to work in the lab, Jason. You have really important work to do. No, this is exactly why we're so glad that he could be online, because often scientists aren't able to publish their data. They're not able to make it public until they have a full, complete story all ready to go. So it's wonderful to have our scientists joining us online where they can give us this live research updates, really exciting stuff. So this is bringing us to a close. Are there additional comments that have come in? Beautiful. So thank you to everybody for tuning in. I really do love answering your questions. It's something I certainly look forward to every month. Please keep sending them in. I'm going to be going back online and returning to this thread so that I can answer more questions that come in and engage in discussions with you. If you enjoyed this video, if you learned something, please make sure to like it and share it, because we really need to raise awareness about the important work that is being done and that still needs to be done. And if you haven't already, please consider signing up for the Foundation Fighting Blindness e-news. There's a description about how you can do that in the description above. Our e-news goes out the first Tuesday of every month, and it's always full of latest breaking research stories like the ones I've just been talking about. And there's one thing you can be sure about research is there's always going to be something new to talk about, because Jason's just one person working in the lab, and there's people across Canada who are being funded by the Foundation Fighting Blindness and around the world who are working on this every day. So you can be sure that by the time May rolls around, there'll be tons of news stories and exciting developments to talk about. I love talking about research. I hate to say goodbye, but I look forward to seeing you all again next time. Thank you for tuning in. Bye-bye.